Hello friends, welcome back to my YouTube channel Infinite Knowledge, and I am back again with another MATLAB Simulink project, and which is specifically for the power system protection subject. So what I have developed the IDMT relay, inverse definite minimum time delay. So you can see here, just a basic. I am just giving you some basic idea about my simulation. You can see we have taken the 11 kV supply from the grid. Then there is one transformer 11 by 415 volt, 11 kV by. It's a 2 MVA transformer. Then one breaker, and this is our industrial load. Okay, and yes, I have developed a relay by some formulas that we have used to make the IDMT relay. We will go this all the parts uh, in brief soon. So I am just again get back to our uh, PPT presentation, which will give a idea about the simulation very well. So let's get started without wasting any time. So it's a IDMT relay as MATLAB Simulink. What is IDMT relay? Inverse definite minimum time delay. What it's mean? As your current is increased, your time to trip is decreased. So here your current graph and here your time graph. So as your current is increased, your time is decreased. So inversely proportional. As your current is high, your time to trip is low. As your current is low, the time to trip is high. Okay, this is a high, this is a low. The time. Okay. So what we will cover in this PPT is introduction, working principle, block diagram, circuit simulation. Then we will check the time to trip calculation. Then standard curves, standard inverse curves, which is specifically for IDMT relay, and reference. So I am just giving you some idea about the overcurrent relays. Overcurrent relay are the protective devices. Obviously, it's protective device such as MCBs that we are using in our household protection. It is it's isolate the faulty part from the system whenever any abnormality occurs. This is why the relay are used, or relay are called the brain of the protection system, because it's continuously sensing and check whether the current taken by our load is high or not. If it is high, then it isolate the circuit and save our another equipment. And the types of the relays are electromagnetic relay, which are now isolated or obsoleted. Then static relays, in which we have used mostly electronics components such as diodes, thyristor, MOSFETs, etc. And numerical relay are the microprocessor based relay, which is the latest in trend. The inverse characteristics of the overcurrent relay response inversely proportional to the fault magnitude, as we have already seen, inversely proportional to, because time is inversely proportional to the current. Okay, so as your current is high, your time to trip is low, and as your current is low, your time to trip is high, as you can see very clearly from this graph. That's why it's called the IDMT relays. Okay, here consider the short circuit protection. During the short circuit, the current is going to the 5 to 12 times. So it's not only protects against the overcurrent. The relay that I have designed in the MATLAB simulation, not just for the overcurrent protection, it will protect against the short circuit as well. We will check it in the next few slides. So this is some actual picture or pictorial representation of the relay. This is the IDMT relays, and this is a specifically for the electromagnetic relay. You can see there is a coil and there is a magnet arrangement. You need to manually set this. Then there is some static relay, which is from the transistor, and the diodes and the MOSFETs are used to make this static relay. And there is a numerical relay, which is a microcontroller and microprocessor based relay, which is latest used in the industrial applications. So what is the basic working principle of the microcontroller based relay? It's IoT relay, and it's a fast and accurate. Why it is fast and accurate? Because there is a the moving parts in this electromagnetic relay. That's why it takes time, and it is not as accurate as this relays, because totally working on the bit level and the digital uh, 1-0 concept, like a binary concept or binary level. So that's why this is the very much accurate compared to the electromagnet. Basically, relay has a current sensor. Obviously, you can see the CT, current transformer also, which sends the current, and which is in the analog signal that's converted into the digital signal. This is the all the things is happening in this static relay as well as the numerical relay. Okay, and the processor check, obviously there is processor which is continuously check whether the current that is in the limit or not. So if you have the MCB which is a 6 ampere MCB, so 6 ampere MCB continuously checking the whether the ampere is less than 6 or greater than 6. So if the ampere is greater than 6 ampere, there is some time delay, and after some time delay the relay the MCB get tripped. So what is the time delay depends on, because in our MCB there is a thermocouple. So thermocouple is like a two metal connected each other. As the current flow above the limit, these two metal cause the thermocouple concept, and the metal get bent. So if one of the metal get bent, the contact will get open, and this is depend on the thermal effect. Whether in this processor type, in this advanced numerical relay, there is processor which continuously sensing and calculating the data, and if the current is higher than the limit, then after some particular amount of time the relay will get. Why particular amount of time? That we have already focusing here the IDMT relays, inverse definite minimum time relay. There is another relays also. You can see from this graph the time to trip and the current. So as your current is high, your time to trip is low at this stage, and as your current is low, your time to trip is high. Okay, that's why it's called the IDMT relay specifically. There are some another types of relays also there, like a definite time. What is a definite time? So if your current is greater than 6 ampere, like consider the 6 ampere MCB. So after some particular amount of time, like if I set a 10 seconds, so after a particular 10 second, my relay will get, no matter, it will not change the time based on the current level, just it get tripped. So that's why it's a fixed time. You can see here definite time. There is a IDMT characteristic is also that this one, second one, inverse definite minimum time delay. So it will continuously checking the current. If my current is suddenly increased, it causes the sudden tripping. Okay, and the time to trip is lower if my current is higher, and if my current is low, then it will take the high time. Then inverse, very inverse and extreme inverse are also there. Very inverse and extreme inverse there is used for particular a specific purpose, like a special motor where you need to get a very inverse. So there is the sensitivity of this very inverse and extreme inverse is very high, but in most industry we are using the IDMT correction. For the special purpose we are using this too. Okay, in most industry we are going with the IDMT correction, and there is some formulas also. You can calculate the time to trip. So if the current is greater than, like if I set, if I use the MCB is 6 ampere MCB and my running current is 10 ampere. Okay, my load is taking the higher ampere and my set ampere is 6 ampere. So by this two value we need to put here. IF means fault current. So fault current is a 10 ampere, and what is the set ampere? Set ampere is a 6 raised to 0.02 minus 1 into 0.4. What is the TMS? TMS is a time. So if how, in how much time, or in how uh, uh, in in what amount of time you need to trip the circuit. So it vary from 0.1 to 1. So as if you consider 1, the time is high, and if you consider a point 0.1, obviously it is in the multiplication factor, your time gets very lower. So 1/10 of this 1. Okay, so by changing this value from point 0.1 to 1, we can set the time as per our requirement, and we are mostly following the standard inverse. Okay, then there is a very inverse curve, extreme inverse curve, and long inverse curve is also there for the earth fault protection, which is used for the special purpose. And this is just a block diagram. You can see there is a CT which is current sensor, or you can say current transducer, which is sense the current and go to the relay. And there is one relay coil. Relay continuously check the ampere whether it is high or not. If it is high, and then if it is high, then after a particular amount of time that defined by this formula, after that time the relay will get tripped. That's why it's called the IDMT relay. Okay, so I hope you at this stage you understand the basic of the IDMT relays, and all the another relays are very clear, and we are mostly going with the IDMT. So we are mostly focusing on the IDMT with this formula, and our MATLAB simulation is based on the this formula. Okay, so yes, so this is a MATLAB just a MATLAB diagram that I have just giving you the brief overview again. It's a 11 kV supply that we are taking from the grid, then 2 MVA transformer, and which have the specific rating in India. Mostly we are using 11 kV by 415 volt. That's why I have considered this value. Then one breaker is add circuit breaker, which is continuously in contact with the relay. So if any abnormality has happened, breaker gets off, and here is the signal that I have developed. And this is the some sensing part, and that is illustrated here. This is the sensing part. There is RMS value converter, then we have set ampere. Here we need to set ampere, here we need to set TMS. As you have already aware about, we need to set the TMS all. So we need to set the ampere also. Which ampere? Is the set ampere, set over current value. So above that ampere we need to protect our circuit. So every industry has some particular load. So here you can consider 1200 kilowatt. So it means the uh, if you convert the kilowatt into ampere, you will get an nearly 1500 ampere. Okay, so this is our limit. So you need to set 1500 here in set current value. And if my ampere, and here it is a continuously sensing, if the sensing ampere is going above, like if it is a 1600 ampere, at this state our load is taking more ampere compared to our set value. Set value is 1500, whereas our load is taking high ampere. At this scenario what happened? IDMT relay come to picture. It will calculate some amount of time, and that will display over here this display block. And after that time delay, our circuit breaker will get off. So this breaker will get off, isolated the faulty part. The faulty part is this one, faulty part from the circuit, and save it from the further consequences. Okay, and here is the short circuit protection also, which is a 5 times. If my current is suddenly high due to any type of fault like LG fault or triple LG fault, but at the same time or in some microseconds my breaker will get the isolated. Okay, so there is a two protection is covered in the MATLAB simulation, overcurrent as well as the short circuit. So we will check all the things in brief in the MATLAB simulation. Okay, so this is a MATLAB simulation graph. In normal condition, 1200 kilowatt load is there. If the load is increased 1500 kilowatt in any adverse circumstance scenario, then it's a overload condition, and during this overload condition, the IDMT relay come to picture, and after a particular some amount of time, my breaker will get off. And here one symmetrical fault is developed, because symmetrical fault is a fault which is known as a LLLG fault, triple LG fault, and this is the fault at which my current is going to the maximum compared to any another. So during this fault, my current or fault current is very high compared to LL fault, LG fault, double LG fault, or any type of fault. Okay, so that's why in most power system, all the design is based on the triple LG fault. The worst case scenario, you can say. So this is my MATLAB simulation, and yes, right now I have considered a 1200 kilowatt. So I just changing the 1200 for all the three phase. Okay. So this is my load for all the three phase, and my set ampere is 2000. Okay, and my short circuit ampere is 5000, and my TMS is 1. I consider the TMS is 1. Okay, so you need to set TMS here, you need to set overcurrent here, you need to every time set these two values, this one and this. Okay. The time to trip will be displayed over here. So I just change the color for these two values, because you need to change this two value every time. So it will highlighted by the purple color, so you will get idea easily. Okay, so you can see very clearly the breaker which is directly connected to this final output. Okay, so yes, I just start the simulation and whether check whether my current is higher than 2000 set value or not. So here you will see the load current. Okay, so okay, why this happened? Because this switch is on, which is represent a short circuit scenario, but mostly in normal condition this switch is in the off condition. This means there is no fault in the circuit. Okay, just I start the simulation once again. So you can see very clearly our ampere is 1503. It's a load ampere, and our actual load is 1200 kilowatt on each phase, and our breaker is in the on condition. And you can see there is a time to trip or delay time which is negative. Negative means not considerable, not in the picture. Why not in the picture? Because our set value is 2000 ampere, where our load is only taking 1503 ampere, which means what it means, our MCB is 6 ampere, 6 ampere MCB, and our load is taking only 4 ampere. So it will trip or not? Obviously it will not get trip. So similar situation is occur here. Our site ampere is 2000 and the load is only taking this much amount of ampere, which is lower than 2000 ampere. That's why our uh, relay will not come to the picture and does not trip our circuit breaker. Okay, so it is in the limit. So what if I reduce this limit? I just reduce the limit. So you can see I reduce the limit, but which is obviously higher than 1503. So nothing is happened and the value is in the negative. So what if I reduce the limit less than this amount 150 by just reducing it, and we'll check whether this value is come to the positive. If come to the positive, then after that amount of time my breaker will get off. Right now it is on, 1 means on. So I just reducing it and less than 1503. You can see very clearly I reduce it, so you can see there is some time which is positive. So after a 68 second, this breaker will get off and isolate the circuit. I again reducing the set value which is very lower. So I reduce it. So as I reduce, the time to trip is decreased, which is clearly represent the IDMT characteristic. So I drastically reduce. You can see my breaker will get off. I drastically reduce, suddenly reduce, and my breaker will get off. You can see after a change, if I change the limit suddenly, and I get the sudden trip. Okay. So this is how you can create the IDMT characteristic. I again change this value to the 2000 ampere, and now I will create the short circuit fault. I again start the simulation, and yes, everything is okay because my set current is very higher than the load current. Okay, everything is okay, and this represents a negative value. It means there is a no tripping time, and when if it is positive, then and then we need to be worry about it, and after that time our breaker will get off. So I just switch on the circuit. I just switch on the circuit, which is clearly represent a symmetrical fault. So what if the symmetrical fault happen in the circuit? So I just turn on this switch and check this value, how suddenly this one will change its state to the 0. Okay, I just switch on. Okay. At the same moment my breaker gets off. You can see as I switch on the circuit, at the same moment my breaker is gets off, because our current, you can see the current shoot. You can see as I switch on, which is clearly represent triple LG fault, and it's caused a very high current shoot, and as my circuit sends the value and it suddenly isolate the circuit and it is in the 0. You can see it's happened in just a 20 millisecond. So very high, or less than 20 millisecond. No, it's a 2.6 and 2.65, which is very fast, and it's directly come to the 0. Our current is 0. This is how this simulation is working for the short circuit protection as well. The 5 times. Okay, so the main use of this MATLAB simulation is because there is a lots of ETAP software and lots of power system software are there, which is a costly, and it's a very hard to understand. But with this simple Simulink, we need to just set the load value according to that load and the transformer values. What is a transformer and what is a input supply, we can create, because this all the things will remain same. This IDMT characteristic is standard, there is nothing change. You need to change just the set value, you need to change just the TMS, and this is how you can create the different graph that I have explained here. You can say I have set the current limit to the 1000. So we will check this for this condition for all scenario. So you will get the IDMT characteristic by when TMS is 1, when TMS is 0.8, which is clearly represent the current and time is inversely proportional to each other. So you need not to use any complex software. You can use this just a simulation software, just a MATLAB, and create any type of load as well as any type of situation, and you will get the time to trip, how much amount of time your circuit will get isolated. Understand? So I just creating this scenario for first time. Okay, so you can see first is overcurrent setting ampere. So we need to set the overcurrent ampere to the 1000 ampere. So what is overcurrent value? Right now it's a 2000. I just set is a 1000. Okay. So we are in initial state. We need to set our relay setting. So this is what we are doing right now. Then what is the TMS? TMS value is 1. So it's already 1. Then what is the standard inverse curve? It's the 0.14. It's the standard inverse curve formula that we have already gone this formula, standard inverse curve formula. It's already gone through here, this formula. Okay. And again, what is our load? 1500 kilowatt. So right now I need to change it because previously I have said 1200 kilowatt, which is normal condition. Now I am creating the overload scenario by increasing the load. Okay. So I am just creating the overload scenario. So I have increased the load from 1200 to 1500. Okay. So I have set everything and I will run the simulation and check whether in 1137 is coming over here or not. Time to trip. Okay. Everything is set. I just start the simulation and check 11.37 is coming over here or not. Okay. Why not? Why this happen? Because this breaker switch is on. I need to switch off first. Because the short circuit is in the on condition. The short circuit, there is no short circuit. Everything is healthy. I just isolated the fault. You can see 1137 is there, which is clearly similar to this value, this calculation. So yes, at this stage we need to wait for a 1137. So 20 minutes is a stop time, and after a 1137 our breaker will get on. So our set ampere is 1000 and load is taken 1843 ampere continuously. You can see our load is taking ampere 184, the fixed load. Okay, so our load ampere, and right now our load is 1500. So at this stage we need to wait for 11 seconds. So at this stage you can see we have already reached 9 seconds and just need to wait for another 1 second, 11.38. You can see our breaker is in the on condition right now, one, and our load is taking 1843 ampere and that ampere is a 1000. We need to wait for a 1.38 second, and you can see you can focus over here and here. As it trace over this value, this breaker will get 0 and ampere is get 0. Okay, 0 ampere and our breaker is good. So we will check exactly after 1.38 our breaker gets off or not. Sorry. So you can see very clearly nearly 1138, nearly 113 our breaker gets off. So this is how accurate we are getting the result from the MATLAB as well, and no need to use any high software for a power system protection like a ETAP and etc. Okay, this is how you can create the overcurrent. Similarly, if I consider the very lower time like a point 2, if I change the TMS, everything is same here. Everything is same, just I am changing the TMS value. Here is the TMS 1, here is a point 0.8, here is a point 0.5, here is a point 0.2. So everything is same, load is also same. I just changing the value of the TMS and whether I am getting the tripping in the 2.27 second or not. So we will check it by just changing the TMS value to the 0.2, and everything is same. I just start the simulation and wait for a 2.27 seconds. Again, our load is also fixed 1500. Our current is also fixed 1843, same as the previous one. And you can see the time is also displayed over here 2.27, which is here also displayed by the calculation. And the calculation was I was using this formula TMS, as I already mentioned. Okay, so we need to wait here over here and check exactly after the 2.27 second whether this ampere gets zero, whether this breaker gets off or not. Okay, that's it's take too much time, and the stop time is a 20 second. We are near to it. Okay, you can see after a 2.27 second, exactly after a 2.27 second, our breaker gets off 120, 2.27. Okay, 2.2716. Okay, this is how accurate you can design the any type of system in the Simulink software. So this is the all the curves that I have already explained here. And what is a TMS? It's a time multiplier setting that we are changing over here 1.8.5.2, that already mentioned here 1.8.5.2. Okay, and the graph is also displayed over here, and that similar graph is also displayed over here. Okay, the TMS1 graph, TMS pointed. So as you increase the TMS value, your time to trip is decreased. For same setting, for TMS take a 50 ampere, and for the same setting, TMS point to take only a 10 not a 10 ampere. For a TMS 1, it's take a 50 second. For TMS point 2, it's take only a 10 second. For the same ampere, you can see for the same ampere, it is taking only a 10 second. Whether the TMS 1 taking a 50. Okay, so this is from my side. If you have still any query, just comment it. I will definitely reply. If you want this simulation file, you can connect with me through my email ID that is given in the description box. For any type of MATLAB project, for any type of electronic project, electrical project, you can connect with me through my email ID that is given in the description box. Thanks for watching. If you have still any query, just comment it. I will definitely reply. Again, thank you. Thanks for watching.